There is a temperature at which rubber seals cease to function, at which titanium begins to soften, at which the distinction between solid and liquid becomes a question of pressure rather than heat. On the surface of Venus, that temperature was passed long ago. The current reading is 467 degrees Celsius. Not in volcanic vents or impact craters, but everywhere the average, the ambient, the condition you would measure if you stood anywhere on the planet's surface for the 2 hours it would take before your instruments failed, lead melts at 327 degrees. On Venus, lead pools. This is not an analogy, this is not harsh. This is the termination of chemistry as a route to complexity. The atmospheric pressure is 92 times what you experience standing at sea level on Earth. It is the pressure you would encounter 900 meters below the ocean surface, where the weight of water above you has compressed every gas space in your body to a fraction of its original volume. Except on Venus, it is not water pressing down. It is carbon dioxide, 96% of an atmosphere so dense it behaves almost like a fluid. The clouds are not water vapor. They are sulfuric acid concentrated enough to dissolve metal, suspended 50 kilometers above a surface no human instrument has photographed for more than 2 hours before succumbing. The Soviet Venera 13 lander, built to survive 30 minutes, transmitted for 127 minutes before its systems failed. It sent back images of a flat plain strewn with volcanic rock under an orange sky, then silence. That is the current condition. That is what Venus is now. But I am not interested in what Venus is. I am interested in what it was, and how long it was that way, and when that ended. If you run the models backward, if you take the current state and trace the planetary history in reverse, you arrive somewhere unexpected. Not at a Venus that was always hostile, not at a world that formed hot and stayed hot. You arrive at oceans, not hypothetical trace water locked in minerals, oceans. Liquid water on the surface, stable for long enough that the word ocean is not metaphor but the most accurate term available. The models are not speculative. They are built from orbital data, atmospheric composition, isotopic ratios, and the mathematics of planetary energy balance. They converge on a Venus that, for perhaps 3 billion years after its formation, maintained surface conditions temperate enough for liquid water. 3 billion years. To contextualize, Earth's oceans are approximately 4 billion years old. Life on Earth is at least 3.5 billion years old. Venus had a comparable window. The evidence is in the deuterium. Deuterium is hydrogen with an extra neutron heavier, rarer, less likely to escape a planet's gravity. When you measure the ratio of deuterium to hydrogen in Venus's atmosphere today, you find it is 100 times higher than the ratio on Earth. That is not a starting condition. That is the signature of loss. Hydrogen escapes more easily than deuterium. If an atmosphere loses hydrogen over time, the deuterium ratio climbs. The current ratio on Venus implies that the planet once had at least as much water as Earth currently holds in its oceans, possibly more. That water is gone. It did not sink into the crust. It did not freeze at the poles. It was disassembled water molecules split by ultraviolet radiation into hydrogen and oxygen, the hydrogen lost to space, the oxygen bound into surface rock or stripped away by the solar wind. The deuterium remains, a forensic trace of what was there. So Venus had water. It had it for a long time. The models suggest surface temperatures may have been between 20 and 50 degrees Celsius for billions of years warmer than Earth, but within the range where water remains liquid, where organic chemistry proceeds, where if you were standing there you would need protection from heat but not from instant annihilation. The rotation was already slow. Even then, Venus turns on its axis once every 243 Earth days, and it turns backward, retrograde, the sun rising in the west and setting in the east. This is unusual but not disqualifying. The thick atmosphere would have redistributed heat efficiently enough that the temperature difference between day and night was small. A slow rotation is not incompatible with habitability. It is simply a different kind of day. Whether life actually began on Venus is a separate question, and one I cannot answer. The conditions were present, the chemistry was possible. 3 billion years is enough time for something to happen if it is going to happen, but we have no evidence either way because the surface we would need to examine has been erased. 700 million years ago, something changed. Not gradually, not over the kind of time scale that allows adaptation or migration catastrophically. The best reconstruction we have suggests a global resurfacing event, volcanic activity on a scale that remelted significant portions of the crust, releasing carbon dioxide trapped in rock back into the atmosphere in quantities sufficient to alter the planetary energy balance. Carbon dioxide is transparent to visible light, but opaque to infrared. Sunlight passes through, heats the surface, and the surface radiates that heat as infrared radiation. But if the atmosphere is thick with carbon dioxide, the infrared cannot escape. It is absorbed, re-emitted, absorbed again. The surface warms. As the surface warms, any remaining water evaporates. Water vapor is also a greenhouse gas, more effective than carbon dioxide at trapping heat. More water in the atmosphere means more warming, which means more evaporation, which means more warming. This is not a cycle. A cycle implies periodicity, something that completes and begins again. This is a feedback loop. It continues until there is no more water left to evaporate. Once the process began, there was no mechanism to stop it. On Earth, carbon dioxide is removed from the atmosphere by weathering rain, combines with carbon dioxide to form weak carbonic acid, which reacts with silicate rock, and the carbon is eventually locked into carbonate minerals and subducted into the mantle through plate tectonics. This is a slow process, but it is a thermostat. If the planet warms, weathering accelerates, removing carbon dioxide, cooling the planet. If the planet cools, weathering slows, carbon dioxide accumulates, warming the planet. It is not perfect, but it is stabilizing. Venus does not have plate tectonics. Venus does not have rain. Once the carbon dioxide entered the atmosphere, it stayed there. And once the water evaporated into the upper atmosphere, it was exposed to solar ultraviolet radiation. Water molecules were split. Hydrogen, being light, escaped into space. Oxygen, being heavier, mostly stayed, but without hydrogen to recombine with, it oxidized the surface rock or was eventually stripped away by the solar wind. The planet was drying out not through drainage but through disassembly. The hydrogen is gone. It will not come back. You cannot remake an ocean from rock. The timeline matters. 700 million years ago, Earth already had multicellular life. The first animals, soft-bodied, simple, but recognizably complex, were present in Earth's oceans. Venus was undergoing a transition that would render it uninhabitable. At the same time, Earth was beginning the radiation of complex organisms that would eventually lead to everything alive today. This is not deep time. This is recent enough that the light from the stars you see in the night sky has been traveling for longer than Venus has been dead. I want to be precise about what dead means here. Venus is geologically active. It has volcanoes, tectonic stress, heat flowing from its interior. Dead refers to habitability. The surface conditions are now such that no biochemistry we know of, no matter how extremophile, could function there. Temperature alone would disassemble proteins faster than any organism could repair them. The pressure would collapse cellular structures. The atmospheric chemistry would corrode any organic molecule exposed to it. This is not marginal uninhabitability, the kind where life might persist in sheltered microenvironments. This is total. The planet's habitability did not decline. It was terminated. And there is no path back. You cannot cool Venus by reducing its carbon dioxide. The atmosphere is too massive, the greenhouse effect too strong. Even if you could somehow sequester the carbon dioxide, the planet has no water left to create the kind of climate system that would stabilize temperatures. You cannot import water in sufficient quantity. Venus would need an amount equivalent to Earth's oceans, and there is no mechanism to deliver that. Even if you did, without plate tectonics to regulate the carbon cycle, the planet would simply heat up again. Venus is not a world that could be terraformed with sufficient effort. It is a world where the physical conditions necessary for habitability have been irreversibly destroyed. The question I keep returning to is not what happened we know, roughly, what happened but why it became irreversible. Earth has experienced greenhouse events. The Paleocene-Eocene thermal maximum, 56 million years ago, saw global temperatures rise by 5 to 8 degrees Celsius over a few thousand years, driven by massive carbon release, possibly from methane hydrates destabilizing in warming oceans. Ocean acidification occurred, species went extinct, but the planet recovered, the carbon cycle continued. Weathering removed the excess carbon dioxide over hundreds of thousands of years. Temperatures returned to baseline. Life continued. Venus did not recover. The difference is not one of kind, but of threshold. Earth's greenhouse event was severe but subcritical. The feedbacks were strong but not self-sustaining. Venus crossed the threshold where the feedbacks became self-sustaining. Once surface temperatures exceeded a certain point, water vapor in the atmosphere was sufficient to maintain warming even without additional carbon input. Once the water was gone, there was no mechanism to remove the carbon dioxide. The planet entered a stable state, but the stability is that of a system that has exhausted its variables. It is stable because there is nothing left to change. This is what I mean by feedback mechanisms that are initially identical to those that make life possible. The greenhouse effect is why Earth is habitable. Without it, Earth's average temperature would be minus 18 degrees Celsius. The atmosphere traps enough heat to raise the average to 15 degrees, and that difference is why water is liquid while life exists. Venus had the same mechanism. For 3 billion years it worked. Then it stopped working. It did not stop because of external catastrophe. It stopped because the internal dynamics of the system shifted past the point where stabilization was possible. The physics of this transition deserves scrutiny. When I say the greenhouse effect worked on Venus for 3 billion years, I mean the planet maintained an energy balance where incoming solar radiation approximately equaled outgoing infrared radiation, modulated by an atmosphere that kept surface temperatures within a range compatible with liquid water. The sun was dimmer in the early solar system, approximately 30% less luminous 4 billion years ago than it is now. This is the faint young sun problem, and it affected all the inner planets. Venus, being closer, received more radiation than Earth, even from a dimmer sun, but not so much more that water could not remain liquid if the atmospheric composition was favorable. Models suggest Venus may have had less carbon dioxide in its early atmosphere than it does now, possibly because the carbon was locked in carbonate rocks on the seafloor, just as it is on Earth. If Venus had oceans, it had a carbon sink. If it had a carbon sink, the greenhouse effect could have been moderate, regulated, survivable. But Venus has no magnetic field. Earth's magnetic field is generated by convection in its liquid iron outer core, a dynamo driven by the planet's rotation, and the heat flowing from the solid inner core. The magnetic field deflects the solar wind, the stream of charged particles constantly flowing outward from the sunday. Without this deflection, the solar wind impacts the upper atmosphere directly, stripping away lighter molecules over time. Mars lost much of its atmosphere this way after its magnetic field shut down, probably due to its core cooling and solidifying. Venus likely never had a strong magnetic field, or lost it very early in its history. This means its atmosphere has been exposed to solar wind erosion for billions of years. The loss rate is slow but cumulative. Recent observations from spacecraft studying Venus have identified a process involving a molecule called HCO+, 4-mile cation, which forms in the upper atmosphere when carbon monoxide reacts with ionized hydrogen. This molecule undergoes dissociative recombination, a reaction where it captures an electron and breaks apart, releasing a hydrogen atom with enough energy to escape Venus's gravity. This process nearly doubles the hydrogen escape rate compared to previous estimates. It means Venus is losing water faster than we thought, and has been losing it faster throughout its history. The hydrogen escapes. The oxygen, as I said, oxidizes rock or is lost to the solar wind more slowly. The water does not come back. So even during the habitable period, Venus was slowly bleeding water into space. This was sustainable as long as the loss rate was balanced by outgassing from the interior. Volcanic activity releases water vapor along with carbon dioxide. But if something disrupted that balance, if the loss rate suddenly increased or the outgassing suddenly spiked, the system could destabilize. The resurfacing event 700 million years ago was exactly that kind of disruption. Volcanic outgassing released enormous quantities of carbon dioxide and water vapor simultaneously. The carbon dioxide increased the greenhouse effect, warming the surface. The warming evaporated more water, which increased the greenhouse effect further. And the increased atmospheric water vapor meant more hydrogen was available in the upper atmosphere to be split by ultraviolet radiation and lost to space. The loss rate spiked. The planet began to dry out while simultaneously heating up. The two processes reinforced each other. There is a concept in dynamical systems called hysteresis. It refers to systems where the path forward is not reversible by simply reversing the inputs. If you heat a system past a critical threshold, cooling it back down does not necessarily return it to its original state. Venus may have experienced hysteresis. Once the temperature rose high enough to evaporate the oceans, once the atmospheric water vapor content exceeded a certain level, the planet could not return to its previous climate simply by cooling slightly. The water was being lost to space faster than it could be replenished. The carbon dioxide, no longer being removed by weathering because there was no rain, remained in the atmosphere. Even if the volcanic activity ceased, even if the heat input returned to previous levels, the planet could not cool because the greenhouse gases were still there and the stabilizing mechanisms, oceans, rain, carbon sequestration were gone. This is not theoretical. This is what the evidence shows happened. The deuterium to hydrogen ratio is not compatible with the Venus that gradually lost water over 4 billion years at a constant rate. It is compatible with the Venus that had substantial water for billions of years and then lost most of it in a geologically brief interval. The ratio has continued to climb because hydrogen is still escaping, but the bulk of the loss occurred during the transition. The planet went from wet to dry in the time it takes a mountain range to erode, which in human terms is incomprehensibly long, but in planetary terms is a punctuation mark. I think about what it would have been like to be there if anything had been there to observe it. The warming would have been perceptible across generations, perhaps across individual lifetimes, depending on how fast the feedback accelerated. Lakes would have begun to evaporate, rivers would have diminished, rainfall would have become less frequent, then ceased entirely. The air would have grown thicker, hotter, harder to move through. If there had been life, it would have migrated toward the poles, toward higher altitudes, toward any remaining bodies of water, and then those refuges would have disappeared too. Not over millions of years, over thousands, perhaps tens of thousands, fast enough that no evolutionary adaptation could keep pace. Fast enough that survival would have required not adaptation, but escape, and there was nowhere to escape to. But we do not know if there was life. We do not know if there was anything there to experience the end. The only certainty is that the conditions necessary for life, as we understand it, liquid water, moderate temperatures, a stable atmosphere, a source of chemical energy, were present for 3 billion years and then were removed. The removal was total and permanent. And the planet that this happened to is the closest planet to Earth, nearly identical in size and composition, formed from the same disk of material at nearly the same time. The difference between Venus and Earth is not one of type, it is one of degree and timing. Earth is positioned at 1 astronomical unit from the Sunday, Venus is at 0.72 astronomical units. The difference in solar radiation received is approximately 90% more for Venus than for Earth. That is significant. It means Venus was always warmer, always closer to the edge of the habitable zone. But the habitable zone is not a fixed boundary. It depends on atmospheric composition, planetary rotation, ocean coverage, albedo, diffraction of sunlight reflected back into space. A planet with high albedo, with reflective clouds or ice caps, can remain habitable closer to its star than a planet with low albedo. Venus, with its thick cloud cover, currently has an albedo of about 0.75. It reflects 75% of the sunlight that hits it, but that high albedo is a consequence of the sulfuric acid clouds which formed after the oceans evaporated. Early Venus, with water oceans and possibly less cloud cover, would have had a lower albedo, absorbing more sunlight. This is another feedback. As the planet warmed and the oceans evaporated, the cloud cover increased, raising the albedo, which should have cooled the planet. But the greenhouse effect from the increased water vapor and carbon dioxide overwhelmed the cooling effect of the higher albedo. The feedbacks did not balance, they compounded. The continuously habitable zone of our Sun, the region where a planet could maintain liquid water over billions of years, is estimated to range from approximately 0.95 1.37 astronomical units, though these numbers depend on assumptions about atmospheric composition and planetary characteristics. Earth at 1 astronomical unit is comfortably within this zone. Venus at 0.72 astronomical units is outside it. But outside does not mean habitability is impossible. It means habitability is unstable. It means the planet is closer to the threshold where feedback mechanisms can become self-reinforcing rather than self-regulating. Venus existed in that unstable region. For 3 billion years, it maintained habitability despite the instability, then it crossed the threshold. The question is whether Earth could cross a similar threshold. The mechanisms are different. Earth has plate tectonics, a magnetic field, a different atmospheric composition. But the physics of the greenhouse effect is identical. Water vapor is a greenhouse gas on Earth just as it was on Venus. Carbon dioxide is a greenhouse gas on Earth just as it is on Venus. If Earth's temperature rises, more water evaporates, increasing the greenhouse effect, raising the temperature further. This feedback operates on Earth. It is currently limited by other processes. Increased evaporation leads to increased rainfall, which removes carbon dioxide through weathering. Increased cloud cover can increase albedo, reflecting more sunlight. The feedbacks on Earth are so far stabilizing, but they are stabilizing because the temperature increase has been modest. If the temperature rise were large enough, if the feedbacks were strong enough, the stabilizing mechanisms could be overwhelmed. Earth could enter a regime where the feedbacks compound rather than balance. I am not predicting this will happen. I am observing that the mechanisms exist, that they are not hypothetical, and that we have an example of a planet where they were not sufficient. Venus is not a cautionary tale because tales are constructed narratives with implicit moral lessons. Venus is a data point. It is evidence that planetary habitability can be terminated by atmospheric feedback mechanisms that are initially indistinguishable from the mechanisms that sustain habitability. The transition from one regime to the other is not gradual, it is a threshold effect, and thresholds by definition are not apparent until you cross them. I think about the timing. 3 billion years of potential habitability, possibly hosting life, possibly not, and then a resurfacing event, volcanic, catastrophic, but not unprecedented in planetary history, that triggered a transition from habitable to uninhabitable within a window short enough that if you could watch it happen, you would recognize it as catastrophe rather than climate. And it happened recently enough that Earth already had complex life when Venus lost its last ocean. There is no way to know what was there. The surface has been remelted, reformed, obliterated by heat and pressure and time. If there were oceans, they are gone. If there was life, it left no fossils we could reach. The planet we observe now is the end state, not the process. But the chemistry tells us the process occurred. The deuterium ratio is not ambiguous. The atmospheric composition is not ambiguous. Venus had water, Venus lost water, the loss was total. I am left with the recognition that habitability is temporary. Not in the sense that all things end eventually, that is trivially true. Temporary in the sense that the conditions permitting life are the result of feedback systems that can shift from stabilizing to destabilizing without external cause. Venus is a planet that destroyed its own habitability not through intent or agency, but through the same atmospheric physics that once sustained it. The process was gradual until it was not. And once it crossed the threshold, there was no reversal. The window closed. It will not reopen. Not in a million years, not in a billion, not ever. The surface of Venus is 467 degrees Celsius, the pressure is 92 atmospheres, and the sky is full of sulfuric acid. That is the permanent condition. That is what it means when habitability burns out. 700 million years ago, that is when the planet that could have had life became the planet where life is impossible, the arithmetic is exact, the timeline is known, and the world that this happened to is close enough to Earth that we call them twins,